Hello, we're going to be starting chapter 9, which is the first section, 9.1 Mathematical Patterns. To start off with, it says generate a sequence using an explicit formula. For the first problem, we have a to the n equals 3n minus 2. So this is the explicit formula we're going to use. Our n just represents the term number itself. So it says find the first 5 terms of the explicit formula. So if we want to find the first term, we're just going to plug in 1 for our n to figure out what the first term of our sequence is. So if we substitute in 1, you'll notice we have then 3 times 1 minus 2. We leave everything else in the equation alone. So 3 times 1, we get 3, and minus the 2, we get 1. If we're going to put this into our calculator, just make sure wherever the n is, we're putting that number that we're substituting in inside parentheses. So 3 times 1 minus the 2. And we get 1 that way. Now if we want to find the second term, instead of having to retype that entire equation in, just go to second entry. Notice it retypes it, and then we can just scroll back and type in a 2. And so our second term is 4. And then if we want to find the third term, we can go to second entry, arrow back and type in 3. To get our third term is 7. To find then 4, go to second entry, type in 4. So the fourth term is 10. And then to find the fifth term, we go second entry, scroll back and plug in 5 and get 13. So our first 5 terms of our sequence is 1, 4, 7, 10, and 13. And some of these problems will be easier like this. We can do it mental math, but if the equations get more tricky, you can definitely use that feature of your calculator, second and entry, so you don't have to retype each equation. For number 2, our explicit formula is a to the n equals 12 times n plus 3. For this one, notice instead of finding the first 5 terms of our sequence, it just wants our a to the 12. So they want to know what is the 12th term of our sequence. So if we want to find the 12th term of our sequence, we're just going to plug in 12 for our n. And so we have 12 times 12 plus our 3. We can either use order of operations to simplify this down, or we can just plug it into our calculator. So 12 times 12 gives us 144, plus our 3 gives us 147. So the 12th term of the sequence would be 147. Next, I would like for you to write these 2 definitions down. For a recursive form, you are relating each term to the term before it. And then explicit form is you're relating each term to the term number itself. Okay, now I'll explain the difference between both of these as we're going through. So we're going to start off with writing recursive definitions. And again, recursive means we're relating it to the previous term. Alrighty, so our first example, we have this t-chart here, and we're trying to find a pattern either going and relating it to the previous term, so some pattern going this way. And notice we're adding 2, and then we add 3, then we add 4, add 5, add 6. There's a pattern to it. It's increasing by 1 each time, but it's not a constant pattern. So we want to find a different pattern that's maybe a little bit easier to work with. So the other way I would look for the pattern is these diagonals. And notice when I take 2 plus the 1, I get 3. 3 plus 3, I get 6. 4 plus 6 is 10. 5 plus 10 is 15. 6 plus our 15 equals 21. So how I'm going to write this, I am to get this number, or a to the n, I'm using the n, so I would write it as a to the n equals n, and then I'm adding the previous term, so n plus a to the n minus 1. And that a to the n minus 1, that just means previous term. Okay, and so with our recursive formula, we're always going to have the a to the n minus 1 using that previous term somewhere in our equation. So let's look at the second one. And again, we want to look for the pattern going up and down like this, relating it to that previous term. And if we can't find a pattern that way, we want to use the diagonals. So it's adding 1 and then it's adding 4, so that's not consistent. It's multiplying by 2, but it doesn't keep multiplying by 2, so that's not consistent. So I would go ahead and start looking at the diagonals and see if there is a pattern that way. Now notice when I multiply these diagonals, it gives me that term. So 2 times 1 is 2, 3 times 2 is 6, 4 times 6 is 24, 5 times 24 is 120, and so forth. So how I'm going to write that to get to this a to the n, I'm taking my n term and I'm going to multiply it by my previous term. So it'd be my a to the n equals my previous term times my n term. So to get to this term, again, I take my previous term times my n term. And so then that will be my equation. Alrighty, let's keep working with some other recursive formulas. So for this next one, again, we're looking for the pattern up and down. We're using our diagonals for recursive. Now this one, notice, instead of using the diagonals, I see they're adding 7 each time. So how I'm going to write that, it's my a to the n equals my previous term, so a to the n minus 1, plus 7. So it'll be formatted like this. This a to the n minus 1, again, just means previous term. So I'm taking the previous term, I'm adding 7 to get to the next term. Taking the previous term plus 7 to get to the next one. Alrighty, this next one, I'm looking at my up and down first to see if I can find a pattern. And for this one, it looks like I'm adding 2 each time. So I'm taking my previous term plus 2. So it'd be a to the n equals a to the n minus 1, my previous term, plus 2. So if we can just remember that the previous term, how we're going to write that is just a to the n minus 1, and that n minus 1 is lowered, then they will always be included in our recursive formulas. The next one is writing an explicit formula. So for this one, explicit means that we're relating it to the term number itself. So if we look at this one, instead of relating it to the previous term, so up and down in this column or diagonal, we're looking across for the pattern. Okay, so I'm going to make these lines to help us. So we want to know, how can we get from 1 to 7, 2 to 14, 3 to 21, 4 to 28, 5 to 35. And each time, notice I'm taking this n term times 7 to give me my a to the n. So that's going to be my formula, a to the n equals 7n. Notice in the explicit formulas, I'm not relating it to the previous term, so I'm not going to have an a to the n minus 1. Alrighty, for this next one, again, I'm looking for the pattern going left to right. Okay, this one's a little bit more tricky to see, but it's a little bit easier as you go further down. So notice if I double this number and add 1, I get to this number. So 5 times 2 is 10, plus 1 is 11. 4 times 2 is 8, plus 1 is 9. So I'm doubling this n column. Since I'm doubling it, I'm multiplying it by 2. So 3 times my 2, add the 1, I get to 7. So to write that, I'm going to say 2 times my n column plus 1. So a to the n equals 2n plus 1. And then from there, if it would have a follow-up question, what is the 20th term, I could just plug in 20 in for my n, take 2 times 20 plus the 1, and I could get what my 20th term was. So explicit formulas are going to be really nice if I don't know that previous term, that I could easily just use this equation to find whatever term number I would like to. Now the last example, again, we're looking for the pattern left and right. And notice I'm taking this n column and I am multiplying it by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So I can either write that as a to the n equals n times n as an acceptable answer, or just a to the n equals n squared. Either would work. Always make sure if you're plugging in these numbers into your equation, check to see if they work. So if I plug in 6, 6 squared is 36, or 5 squared is 25, it's working. Or I can plug it into this top one, 5 times 5 is 25. So again, either equation would be fine.